UML, the Unified Modeling Language, which is really more about drawing pictures than it is about a language. But we wanted to introduce just enough of it that, first of all, we can use it for examples. And second, you can probably use it in some of your informal design documents when you're thinking about how to delegate responsibilities to different classes in your app. So it's a notation for describing various kinds of things in object-oriented systems. We're going to use the UML class diagram pretty extensively throughout these examples. And it's actually pretty widely used even by people who don't otherwise use a lot of UML. You can show, because you can use it to show relationships, very basic relationships among different class types. So in this simple example, we've got a vehicle class, a car class, and an engine class. And the open arrow is telling us that car is a subclass of vehicle, so classic inheritance. The closed arrow is telling us that engine is a component of car. So what does component mean? It means that among other attributes, one of car's attributes is an engine object, right? That would be one way to say that it's a component, that there's properties the car has. Some of them are just simple values, but some of them are essentially handles to another class. And down here in the bigger box is where you would put both attributes and instance methods defined on the class. Now, of course, technically in Ruby, there are no separate attributes. Everything is a method. But since a lot of methods really are just accessors for what really are attributes, we can think of both attributes and methods going into the box here. And you don't necessarily put all of the methods in here, but you put in the ones that are most important to either understanding the role of the class or understanding how it would interoperate with other classes. You can also express relationships of the kind that associations are used to model. In other words, relationships between types of classes. For example, when you've got an arc connecting two classes, here account code and item are two classes. You could see that item has attributes like price and sold on, and it's got methods including transfer to customer and refund. The little open diamond means that the relationship between account codes and items is an aggregation. So for every one account code, there's 0 to infinity number of items that are associated to it. So it's like a has-many relationship in active record. There's also the solid diamond, which indicates composition. And the basic difference between a composition and an aggregation is that in a composition, the owned objects don't make sense without the owning object. So here we're saying that a customer has many items, and if that customer stopped existing, it wouldn't make sense to talk about the items because there's nobody for them to belong to. Whereas there's a one-to-many relationship from account codes to items, but just because you change or delete what the account codes are, the items wouldn't stop existing just because the code got changed out from them. So both of them express one-to-many relationships. And in fact, syntactically, you often implement them the same way. But in terms of understanding the semantics, that's why there's two different notations in the diagram. And as we saw, there's the open arrowhead, which is classical inheritance. I am a subclass. So in this diagram, both donation and voucher are a subclass of item, which, as you guys remember from an earlier example, there was a question to which the answer was donation and voucher shouldn't be a subclass of the same thing. I put that example in because I actually made that mistake, and I'm now painfully refactoring my way out of it. So there. As I said, I keep saying I'm not going to actually explain anything unless I have done it myself, so you can hold me to that. I said we're going to do just enough UML. Here's too much UML. This is a UML diagram showing all the different types of UML diagrams. The red box, the class diagram, is the one that we just showed some examples of. It is a logical subclass of a structure diagram, which is logically a subclass of diagram. So all of these are different types of UML diagrams, none of which, other than class diagrams, we are ever going to draw in this class. Not to say that they aren't important. They have some useful cases. For example, if you look at use case and activity diagrams, they look a lot like stick figure versions of user stories. They actually show stick figures interacting with some particular data object that's modeled by a class, and the interactions show a flow of what the stick figure is doing as they interact with that class. So from your point of view, that's really a lot like scenarios in user stories. One reason that UML actually became very popular is if you draw your UML diagrams to represent the things that you want implemented, in a way it's language independent, right? Because it's boxes and arrows. So if you're communicating with an international team and you're trying to build different parts of a project, trying to capture it as UML diagrams may be more precise than trying to capture sort of a written description in prose of what the project parts are supposed to do. So here is a diagram, a class diagram that you can practice on. And I realize you need a couple of minutes to sort of parse the diagram while you figure out the answer to this question. Which active record association type of relationship does not follow from this UML diagram? Show has many vouchers through show date. Item has one account code. Customer has many donations. Voucher belongs to voucher type. So take a moment to parse the diagram, and then we'll see.